Bright QT. Every student matters.
Before talking in detail about the magnetic effects, let us study a bit about what exactly magnetism or magnet is. We know that a normal simple magnet, whatever we have seen till now, is just like this, right? It is a bar magnet. This is what we have seen, the normal most common shape bar magnet, which has two poles, north pole and south pole. Now, a magnet has a unique property that if you cut this magnet from in between, still it will exist in two poles, north pole and south pole. Again you will cut it, it will still exist in two poles, north pole and south pole. Even the smallest sized magnet exists in two poles, north pole and south pole, right? And we know, just like electricity, in magnetism also we know that like poles, by saying like poles I mean to say north and north pole or south pole, they repel each other, whereas the unlike poles, that is the opposite poles, north and south, they will attract each other. This we already know, right? Fine. This magnet is a bar magnet. It may be a circular or a button magnet, or it may be this kind of a horseshoe magnet. There are different varieties or shapes in which magnet comes. This is the north pole, this is the south pole, right? So we will be talking just right now about bar magnets. Fine. Now students, we will see an activity to find how iron fillings align themselves along the field lines. For this, we will be requiring certain material. What all materials are required to conduct this activity are: we will be requiring a bar magnet, we will require a wooden table, we will require a stiff white cardboard, we will be requiring iron fillings and salt sprinkler. Right? Now, to perform this activity, let us proceed. First of all, what we will do is, we will place a bar magnet over a wooden table in north-south direction. Okay? Now, over the magnet, place a stiff white cardboard. Now, fill an empty salt sprinkler with fine iron fillings and sprinkle the iron fillings on the stiff cardboard as shown in the figure. When you tap the stiff cardboard gently and make your observations, you will see what exactly at the moment you are observing in the video. You will see that these iron fillings arrange themselves in a particular pattern. Now the question arises, why do iron fillings set themselves in a particular pattern? The answer why it happens is because obviously the bar magnet exerts its influence on the iron fillings in a region around itself and forces them to rearrange in a particular pattern. So when we did this activity, we saw that how iron fillings align themselves along the field lines. Now let us define the magnetic field lines, and for that we will perform another activity. Let us see how. I will take a bar magnet once again like this. Fine. Let us say this is a north pole and this is the south pole. Now what I will do is, I will keep a magnetic compass here. Fine. Now I will just see where exactly the pointer of the magnetic compass points, and I will put a mark at this particular point. Then I will just take the compass out from here and I will place the compass at this particular point where I have marked, and now once again I will see where exactly is the pointer pointing. Now where exactly the pointer is pointing, I will once again place a mark out there. Again I will just take this magnetic compass out from here and place it on this particular point. Again I will see where the pointer is pointing and I will place the mark. Same I will continue doing, and I will find that this pointer is going like this. If I am doing it below also, I will find, putting up the marks, placing the magnetic compass, I will find that this is the way the needle will move. Right. So, with this particular activity, now I am in a better position to define the magnetic field lines. How I will define magnetic field lines or magnetic lines of forces? Magnetic field lines are the lines of forces along which the north pole of a magnet moves. These are the lines of forces along which the north pole of a magnet moves. Right? Let us see in detail what we have written. This is the north pole. This north pole is moving like this. It is going towards the south pole. The direction is this. In the downside also, we find, joining these and connecting these points, we see that the north pole with the direction I can show is moving in this direction. So, this is magnetic field line. Similarly, we have all the magnetic field lines like this, which are moving from north pole to the south pole outside the magnet. It is just like this. Just not exactly a kind of mess I actually wanted, but I hope to make you understand, I need to make these few. These are all the magnetic field lines or magnetic lines of forces. The direction of all these magnetic field lines is always towards north pole to the south pole. This we need to remember. Fine.